Good morning, everybody. My name is Michael Washam. I'm a senior program manager on the Windows Azure Runtime team. Specifically, I own two pieces in Windows Azure. The Windows Azure PowerShell Cmdlets for compute, so virtual machines and cloud services. And my team also builds the Windows Azure SDK for cloud services. So if you're a Windows Azure developer and you build cloud services, or you deploy and manage them, either one, most of that work comes out of my team. Before I get started, just want to kind of quiz you guys on what all you actually use out of Windows Azure. For starters, how many of you are using Windows Azure PowerShell today? Oh, very good. How many for virtual machines? How many for cloud services? All right, so that's exactly what I wanted to hear. So for those of you that are new to using the PowerShell Cmdlets, I'm going to kind of give you the crash course on some of the basics of what you can actually do with the PowerShell Cmdlets. PowerShell is all about automation, being able to do one thing many times in a repeatable way. So the very first bullet I like highlighting is all the different pieces that you can actually automate. Want to make it clear that you can query, manage, configure pretty much, not exactly all of them, but the majority of the Windows Azure resources you can create in the cloud, you can automate and configure that from the command line. This includes virtual machines, cloud services. If you're into Windows Azure websites, we have websites cmdlets now, storage queues, databases, etc. One of the real big advantages of using PowerShell is if you're managing multiple subscriptions and multiple storage accounts and data centers, you can actually write single scripts that work across these subscriptions and different data centers. Next thing I want to call out is whenever you're provisioning workloads using infrastructure as service with virtual machines, one big significant difference between using PowerShell and the portal is you can provision fully composed virtual machines. All that really means is if you're used to working in the portal, you go to create a virtual machine, then you want to add a disk to it, that's a separate operation. If you want to add 5 disks to it, those are 5 separate operations. From PowerShell, you can create your virtual machine with all the disks and all the networking configured all at once. So whenever you're doing big deployments, multiple servers, you can do this in a very repeatable fashion. Another really critical piece if you're deploying Microsoft workloads, SharePoint, those kind of tasks, is you can boot your virtual machines up that are domain joined. So you don't have to log in and manually join the VM to the domain. This can be started domain joined at provision time. So I got a little animation here, but we have a really cool feature that's not officially out yet. It'll be out in the next few weeks. But we're actually enabling remote PowerShell on all virtual machines created, all Windows-based virtual machines created directly from PowerShell. This will be the default option, so not only can you spin a bunch of virtual machines up, but you'll actually be able to log in and do something useful with them now. So big step forward in automation. From a virtual networking perspective, we have cmdlets to allow you to create and configure your VNets, turn on your VPN gateways, turn them off, etc. And storage. We have been historically really light on. In the past 2 releases, we've added a lot of functionality for managing VHDs. So you can now upload and download VHDs from on-prem to the cloud. And we just recently added capabilities to copy VHDs between storage accounts. So I'll show you some of these here in just a little while. So if you're brand new to Windows Azure PowerShell and you've never got started before, I want to walk you through the crash course on how to get up and running, because it's not the simplest process, and they download the cmdlets and they're like, okay, what do I do next? So this is it. This is the steps you have to do to be up and running in PowerShell. So the first thing you want to do is to actually download the PowerShell cmdlets. These are going to be from the windowsazure.com site. You'll go here, you'll click Downloads, and scroll all the way to the very bottom, and you'll see Windows Azure PowerShell. We release these guys every 3 weeks, so if you downloaded them 3 weeks ago, there's likely a really good set of functionality that's been updated since then. So these rev very fast. We add a lot of functionality to them. We have quite a few developers on them just to get these the cmdlets up to matching our API functionality. So the first thing you do is download and install these on your local machine. From there, you're going to kick off your favorite PowerShell editor. I'm using PowerShell ISE. If you're brand new to PowerShell altogether, all you have to do to start PowerShell ISE is from start run PowerShell_ISE. From there, import module Azure, and this will pull in all the PowerShell cmdlets that we ship that you just downloaded into your PowerShell run space. And to get set up, you need to download a published settings file. You can see we have quite a few commandlets. All this one really does is it kicks you off to a website that allows you to download your subscription settings. So it automates IE for you. Pretty handy, but if you don't know that URL, it's kind of hard to remember. So we'll go ahead and download these. And this is just a text file. It has a management certificate embedded in it and your subscription ID. Okay, I have 2 of them now. Make sure I grab the right one. Now, once you've downloaded this file, you need to import it. And the beauty of this capability is you only have to do this once. We actually persist all these settings in your user profiles directory. So you will see occasionally scripts that have import and every time. If you set this up one time, it's actually persisted in your user profile, so you don't have to run it every time if you don't want to. And the reason you shouldn't do that is because if you have multiple subscriptions, it'll always set the last one that's in your subscription as a default, so you'll have to change it every time. So now that we have our subscription imported, I can run the Get Azure subscription commandlet, and this will show you everything that I have stored. Right now I have 2 subscriptions, the subscription I just imported, and I have another one called MSFT. Now, the reason I have another one called MSFT is because I really don't like typing in TE, blah, 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 the name of the subscription. It's really long and it's hard to remember. So a little trick I can show you, if you want to rename this subscription, is first you want the really long version name. Oops. You have to be able to copy and paste it first. If I just run that, that's just going to pull back the subscription settings for the one I specified. But what I want to do is pipe that out to set Azure subscription and just give it a new name. So I'll call this my MMS subscription. Now when I do Get Azure subscription, I'll have another subscription down at the bottom, except now it's MMS sub, which makes it much simpler to actually type and switch between your subscriptions, and they're much more meaningful. I believe you can actually change that in the Windows Azure portal to the name of the subscription, but if you're lazy like me and just want to do it from the client side, it's much simpler. So now that you have your subscription, the one more thing that you have to do before you can do anything from compute, at least, before you can create a cloud service or a virtual machine, is tell it which storage count you want to use. So to do that, you either A, have to create a new storage count using the new Azure storage count commandlet, or you can enumerate an existing one. So I have a bunch of storage counts already created, so I'm just going to go ahead and call Get Azure storage count. And let me go ahead and up the font size. I bet that's not that easy to read. Is that better? Okay. So Get Azure storage count basically dumps out every storage count that you have in your subscription. And you can do all kinds of fancy things like selecting pieces out of it. So if you don't want to see all of the properties come through. So now that we have all of our storage counts, I'm going to pick one that I'm going to work with. It's going to be MW West Storage. This is a storage count that's in the West US data center. So I'm going to tell it for my MSFT subscription to use this storage count for all future creations. So now the next create command I make, whether it's going to create a virtual machine or a cloud service, it's going to use that as a default storage count. And there's one more commandlet I want to show you. If you do have multiple subscriptions, like I do now, I can use the select Azure subscription to switch between them. So if I want to run a script on subscription A, switch to subscription B and run another script, this is a command that actually switches a context for you. So now that we're set up, let's go ahead and create a virtual machine. That's the easiest one. To create a VM, I want to have a variable that tells what image to create from, and I need to know what the image names are. If you've done this in a portal, you'll see in the gallery a big long list, all our Linux virtual machines, all our Windows virtual machines, et cetera, et cetera. You can get the exact same list from PowerShell using the Get Azure VM image commandlet. It gives you the nice raw data. So you get the raw names. So you can kind of decipher what they are by looking at the in between the dashes. So I'm going to grab the Windows Server 2012 version, the image, to store that in a variable. I have a bunch of my own images in there too, so. Yeah, that is a combination of the platform images that you have and also any custom images that are in your subscription as well. So if you look down at the bottom, I have quite a few of these that are my own. So I'm storing the image name in the image variable, and now I'm going to go ahead and create a virtual machine, and I'm going to use the new Azure VM config commandlet. There's two different ways of creating a virtual machine in PowerShell, new Azure Quick VM and new Azure VM config. New Azure Quick VM gives you similar functionality that you have in the portal, which means that you can basically create a VM, specify the image and username and password, and after that, you have to customize it later. New Azure VM config allows me to compose all the pieces of my VM, set the disks, set the endpoints, cache settings, etc. So I can do everything all at once. So I'm going to go ahead and just call this my VM1. Pick the instance size. I'm going to pick small because they don't let me have a big quota because they think I'll run up a bill. So pick the image I'm going to build off of. And what this does is it actually generates a configuration object. So if I save that and I dump it out to the console, you can see it has all this configuration information in it. I'm not actually creating anything with an API, I'm just really creating a configuration. So how composition works is I'm going to take that configuration and I'm going to pipe it out to another commandlet, that way I can modify it. So the first thing I need to do is add a provisioning configuration. This will tell me, be able to set the password for the virtual machine, what OS it should be, etc. Now, if you're used to using PowerShell today, one thing I will tell you in the next release is don't upgrade unless you have some time to fix your script, because there is a breaking change. We now require you to specify the username whenever you create the VM. So before, it would just default to administrator. Apparently someone figured out that that's not overly secure, so we're now requiring you to pick a username for the default admin account. So I'm going to give it my username and password, and now I'm going to add a few other things. For this virtual machine, I'm going to add a data disk. So I'll add a 500 gigabyte database, call it my data, and put that on 1.0. And if I wanted to, I could actually provision multiple disks here. I could pipe these out, just change the LUN number, and I could literally add multiple data disks to this virtual machine. So whenever it boots up, it would have 3 500 gig disks on it. I can also add endpoints here. So if I know this machine's going to boot up and it's going to be a web server, I can add an endpoint, just call it web. Put it on local port 80 and public port 80, because we do port mapping, so you can have a public port that routes to an internal port. And that will open up port 80 on the load balancer, so now traffic will go back to this virtual machine. And finally, I need to call the new Azure VM commandlet to actually create the VM. And if you're not overly familiar with Windows Azure virtual machine architecture, just know that every time you create a virtual machine, it's actually created inside of another container. The container we call it is a cloud service. You can have multiple virtual machines inside the cloud service, same cloud service, or you can have one virtual machine per. It doesn't really matter, depending on what your architecture is. So this -service name parameter is the public DNS name of that cloud service. This is going to be the public IP address of your VM. So this does have to be unique because we generate DNS off of it. And the final thing we need to do is give it the data center that you want this virtual machine created in. So I'm going to go ahead and pick West US. And now you're wondering, well, how did he know that was called West US? And the way you know that is we have another commandlet that will allow you to enumerate all the different data center locations within Windows Azure. So you can see we have North Central US, West Europe, East US, West US, etc. This will enumerate all the data centers in all of Windows Azure. So I'll go ahead and hit F5, and this virtual machine will start creating. You notice that the first thing that comes back is it actually created the cloud service. So this is that container I was telling you about. We create the cloud service first, if it doesn't already exist, and then we create the virtual machine within the container. If you want, you can actually take out the location parameter, and it will attempt to add it to the same cloud service so you can have multiple VMs in that container. So let me jump back over to the slides. That's kind of the crash course on how to get up and running and create a virtual machine with PowerShell. And that was my demo. So now the question is, okay, so I composed it, it's all great, I deployed it, it's running great, and then I realized that I didn't add enough storage. I have, those 3 500 gigabyte disks, and it's just not enough. I need to add another terabyte or whatever. How do I modify a running virtual machine using PowerShell? We have very similar composition model that during creation that we can use for updates. So the main idea is you call get Azure VM that returns back that same configuration object that you used during creation. We use other commandlets, add Azure Data Disk and add Azure Endpoint to modify that config, and then we call update. Same concept, we're just modifying a config and posting it back to the Windows Azure REST API. Now, if you want to break this out and not see the pipes, because I know there are a lot of PowerShell people that are pretty new to using the pipelines and not understanding that it passes values back and forth, the same idea is we call get Azure VM, we store that in a variable. We call add Azure Data Disk, and we pass that config to that commandlet. It modifies it with the new data disk settings. Same thing with endpoints. And then we pass that configuration to the update call. So relatively straightforward, but until you've done it once, it's not that straightforward. So let me show you real quick just how that works. So here's the PowerShell, or the virtual machine that we just created. I'll go ahead and comment this out. And let me show you a few nuances of get Azure VM. So get Azure VM takes the service name and then the specific virtual machine within the cloud service within that container that you want to work with. So my VM1. So if I run get Azure VM, you'll see that we returned all the config. You can see that it's in starting state. This is the private IP address that within the cloud service. You can see all the instance status and everything about it. Now, if I want to add another disk to it, I take that configuration, I pipe it out, and I can add another data disk. So maybe I need another 50 gigs of storage. And since I already have a data disk at disk 1, I want to add this one to LUN 0. I want to add this one to LUN 1. And then I just pipe that back out to update Azure VM. And just like the new creation, this is composable as well. So I could add multiple data disks at one time, multiple endpoints, etc. So the beauty of this is you can literally make a huge batch updates to your virtual machines in one API call, versus if you're using Portal or other tools, you're going to be waiting for each API call to work. So I'll go ahead and hit update, and this will add another 50 gig drive to that virtual machine. Okay, so let's talk a little bit about the remote PowerShell stuff. Now, as of today, if you go download Windows Azure PowerShell commandlets from the Windows Azure site, this is not enabled. This will be in the next release, which is coming in the next few weeks. So the very next release of Windows Azure PowerShell commandlets, whenever you boot up a virtual machine directly from PowerShell, like I just showed you, those 2 virtual machines that we've spun up already, or that 1 virtual machine that we've created, it is enabled with remote PowerShell already. And how we've done this is it is over SSL, so this is using HTTPS for all authentication and everything. Well, hold on, to be clear, it's not using HTTPS for authentication. We don't use a cert for auth, we just use it for securing HTTPS tunnel. So the authentication is still your username and password that you pass in from the PowerShell, but it is over an SSL tunnel. Now, you have 2 choices for certificate management. You can give us one of your own if you want, or we'll actually create one for you and just use a self-signed cert. HTTP is optional, so whenever the VM is booted up, if you don't know a whole lot about remote PowerShell, there's 2 options. You can configure it for HTTPS and HTTP. Over the public internet, we're obviously only going to use HTTPS, but within your cloud service, VM to VM, you can enable HTTP if you want to. And we have a switch on the new PowerShell commandlet that will enable that, and you can turn it on if you'd like. And the power of this is it basically gives you the ability to remotely monitor your VMs. You can log in via PowerShell, turn on perf counters, do whatever you need to with it. But you can also run scripts on startup. If you're used to using cloud services, this gives you very similar functionality to startup scripts with cloud services. You can basically boot the virtual machine up and then bootstrap it to provision services, install software, or download, do whatever you want to with it. So it gives you a lot more flexibility whenever you start dealing with infrastructure as a service. A few of the niceties that we've added. And we have a flag now for on new Azure VM and Quick VM. It's called wait for boot. And all this really does is it polls and it waits for your virtual machine to get all the way up into a booted state. That way, if you do want to run a script on boot, you don't have to write that looping logic yourself. The next thing we do is, since we do have multiple virtual machines behind a single IP address, we obviously can't have them all listening on the same SSL port. So how that works is each one of the SSL, the remote PowerShell endpoints, is actually on a random public IP or public port. So we didn't want you to have to go into the portal and figure out which one of those maps to remote PowerShell. So we added another commandlet called get Azure WinRM URI that will decipher it for you. It'll basically take your virtual machine, digs through all your endpoints, figures out which one is remote PowerShell, and returns it to you so you can connect to it. And from there, the last two commandlets, invoke command and enter PS session, these are just out-of-the-box Windows PowerShell commandlets. This is literally the code you use to execute script remotely on a VM. So I'm going to show you a real quick demo, and then I have another one that's a little neater. So from PowerShell, what I want to show you is how we can basically create a virtual machine, use the wait for boot functionality, and just whenever it boots up, it'll be logged into a remote PowerShell session. Okay, so what you can see here is on the new Azure VM call, this is the exact same code that I've been showing you on creating virtual machines before, but I have a dash wait for boot flag on it now. So whenever it hits this code, it's actually not going to return until the VM is booted all the way up. From there, I'm using the get Azure WinRM URI commandlet. This takes the service name and the VM name of whichever one you want to connect to. It gives you the connection string with the right port, and from there you can connect to it using remote PowerShell. And the only gotcha is, since I am using self-signed cert, I have to do the PowerShell set option for skipping this certificate authority check. So you do that, and it basically says, yeah, this certificate is really good, don't worry about it. And PowerShell will connect to it, and you can run cool stuff on it. So as you can see, no magic, it's really just going to boot up, and assuming I don't have a typo in the script, it should dump us into a remote PowerShell console. Oh, and see, I have a typo, so. Oh, okay, so it actually wants to know the service name. Imagine that. All right, so what it was complaining about is it wanted to know what name of the virtual machine I wanted to give it and what the service name was going to be. So what I'm doing is I'm calling the get credential commandlet. It's just a base PowerShell commandlet that basically gets credentials for me, and will pass it to the enter PS session later for me to log into. You can script that where it doesn't prompt you, and it can pull from a configuration file or whatever, so you can do automated tasks. So we'll come back to this one. I'm going to try to do the cooking show moment, and hopefully in a few minutes we'll be booted back into a remote PowerShell session. Okay, so one thing that we've been really working on is the ability to have image and disk mobility. So what that really means is taking a virtual hard disk that you have on-prem that you're running in Hyper-V today, maybe it's on your dev machine on your laptop, and maybe it's your SharePoint farm that you're running on your laptop. If you're a SharePoint developer, you're probably one of those guys that carries the external hard drive around for all the disks you have to use to run SharePoint. Using PowerShell commandlets, you can literally take these VHDs, upload them up to the cloud using add Azure VHD, and boot off them. Literally, you can take a bootable VHD and create a VM off of it. In the commandlets we've seen before, we were using base images, but we can boot off of OS disk just as easy. And we also need the ability to take that VHD and take it back down. I mean, this could be for debugging. It could just be because you're tired of Windows Azure and you want to put it back on-prem. Your boss said give up, whatever. The ability to move these virtual hard disks back and forth is a really important feature, and lots of customers have asked for it. And another side benefit of these two commandlets is that they're heavily optimized. And what I mean by optimized is if you have a VHD, say it's 127 gig VHD, and only 30 gigs of it are actually written, so there's 97 gigs of free space, the commandlet's actually smart enough. It reads the VHD format. It doesn't read all of that empty bytes and transmit it anyway, so it'll only upload the 30 gigs that are actually empty. In the same way for download, we actually use the Windows Azure Storage page blob APIs to only read the written 2 bits and write them back down during download. So it gives you a lot faster experience than if you were just using traditional Windows Azure Storage tools. So what these kind of primitives give you is the ability to fully script and automate migration of a VM. So if you have a virtual machine that you want to move to the cloud, you can literally use at Azure VHD, at Azure Disk, and the various commandlets we use to create a virtual machine to take that Hyper-V VM, dump it up to the cloud, and boot off of it. I mean, just 5 lines of code, and you can migrate a Hyper-V VM up to Azure. So I've heard we've had network connectivity issues here, though, so I'm not going to upload a full 50 gig VHD. I don't know if that's true or not, but that's what I am going to do. So I'm going to switch back over here, and I am going to upload a VHD, but it's going to be 50 megs instead of 50 gigs, just to show you the concept here. So I have a little script here, and all it's doing is pointing to my storage demos folder. If you open this folder, you can see I have a 50 meg disk. It's small, maybe it'll actually upload, we'll see. But just imagine that this is some terabyte disk and you're going to upload it and do some really important task. Really, the only thing to do that is these 2 commandlets. You're going to give the destination VHD, which is URL in storage. And let me fix this error too. Oh, my disk already exists. Shame, shame. Which leads me to another example. If you would like to delete that disk, we have another commandlet called remove Azure Disk. That, assuming it's not hooked up to some virtual machine, will actually remove it and delete it out of storage too. So now my disk is gone. Okay, so this is what the upload process looks like. You can see it detected the empty blocks in the data file. Not much, obviously, it's only 50 megs. It's actually really slow for uploading such a small file because we do all this checksumming and validation. It would actually be faster just to upload the 50 megs. But whenever you get into the gigabyte and terabyte range, it's actually very efficient. Okay, so the file has been uploaded. So now I can say get Azure Disk. And you can see that it is actually up in Windows Azure Storage, the disk name, the location, which data center it's in. So what we can do with that is I can go to one of my virtual machines. So I'll go to this SQL 1. Let me log in here. Just to show you why this is interesting, I can go to, usually one tip, if you're working on PowerShell and a portal at the same time, whenever you do operations in PowerShell, it's always a good idea to go back and refresh the portal because sometimes they don't know what you did. So they don't talk to each other that closely. So if you're jumping back and forth like I am, you might have to hit F5 a couple of times. So I'm going to go to attach disk. You can see I have a lot of disks here, but the one I'm interested in is my data disk. So I'm going to go ahead and attach this to a virtual machine. And while this is running, let's switch back to our former demo and see if it's finished. Nope, it's still booting. Now what we should see is we should see this disk surface up in this virtual machine. So eventually you should see another disk pop up here. Not a whole lot of storage left. There we go. And what we can do to demonstrate the save is we can add some content here. Okay. And now we want to go back and detach the drive because it's never a good idea to upload and download or try to save a VHD that's getting written to. So you want to detach it from the VM first. So I'll go ahead and hit detach the disk. And now Windows Azure will remove that disk from my VM. And of course, those two operations could be done from PowerShell as well, but I did want to give you some portal time so you're just not in the console the whole session. So we'll switch back over. And let's clear out this code. Now, instead of uploading it, we're going to download that VHD. So pretty much the reversal. My source is now in Windows Azure Storage. It's an HTTPS URL that actually is in my storage account, and the destination is pointing back to my local hard drive. I'm going to call save Azure VHD, give the source and the local path. And we have downloaded our VHD. So I can go back here. You can see my data disk dash downloaded. I've renamed it on download. And there is our hello from MMS. You have seen the most inefficient way possible to transfer a text file, but it's from PowerShell. Okay, so back to, all right, so the other demo is ready too. So as you can see, our PowerShell console is at our our remote service address, my remote psservice.cloudapp.net. That means any commands I run here is actually running on the remote machine from my local laptop. Oh yeah, not Linux, sorry. Interesting. There we go. So this is all executing remotely. I could have it download files, I could run scripts, I could do whatever I needed to do with it. Okay, I'll show you a little bit more elaborate example of how to do this. Question? So the question was, do we need to change the firewall rule for this access? And the answer is no. Whenever you enable remote PowerShell from PowerShell, this is actually baked into the provisioning process as a virtual machine, and we take care of the certificate generation and configuring the firewall rules for you. You can go in there and tweak it if you'd like, but right. So correct. We did add a firewall rule for the SSL. In Windows Server, I think that's VM to VM, and the rule is local subnet, right? So this machine can ping this machine, and what we've enabled is we've opened up a firewall rule for SSL, so pretty much any endpoint can come in on that SSL if you want to. It's pretty much the same entry point that RDP is today, right? So we looked at it from a security perspective. You know, anyone could RDP into this VM today. Why not enable them to do remote PowerShell? And we've only enabled it for PowerShell, and you can disable this as well. There's a flag on the VM to actually not enable PowerShell. So let's talk about another method of moving VHDs around. So we saw with Add Azure VHD and Save Azure VHD, you can optimize upload and download, but how about moving VHDs across data centers? So we've introduced a new PowerShell commandlet. It's actually called Start Copy Azure Storage Blob today. In the next release, it'll be called Start Azure Copy Storage Blob, I believe. They basically got the name wrong whenever they built it, but that's what it is today, so if you want to go try it, it's there. How this API works is you call Start Copy Azure Storage Blob on some VHD that's already up in the cloud. This could be in Windows Azure Storage, it could be in Amazon S3, it could be anywhere as long as that service can reach it some way through the URL. And Windows Azure Storage will basically goes off to that source URL and starts copying it to wherever the destination is. So what this allows you to do is to create virtual hard disks that, you know, say you created a bunch of virtual machines on the West Coast in West US, and you want to copy them to East US, using PowerShell alone, you can literally copy all those VHDs around. And they don't have, the beauty is they don't have to go to your machine first. Most people, if they want to move virtual hard disks around, they'll either create a virtual machine up in the cloud and use that for copy back and forth, or they'll download it first and then go and upload it. This actually bypasses both of those, and the destination actually copies from the source. So it's much more efficient, it's extremely fast too. So let me show you how you can do this in PowerShell. So I'll get rid of this code. Actually, that is on a remote session, so I need to remember not to use that. So to set this up, it takes a little bit more work. First off, you have to know the source URL. So if you can see this, then this VHD is actually on the West Coast. It's in mwstorage.blobcore.windows.net. It's called testcopy1.vhd. So if I go into a tool like Cloud Explorer, you can see this VHD, testcopy1.vhd. It is 32 gigs. So it's basically a bootable Windows machine, is what it is. That's the source URL, and what I want to do is I want to copy this VHD over to the East Coast. So I have another storage account called MW East Storage that's in the East US data center, and I need to get the storage key. And you can retrieve that key from calling the get Azure storage key commandlet and giving the storage account name, and it'll dump out the primary key you can use for authentication. From there, you need to create a storage context. This basically tells the commandlet which storage account to use for the destination copy. Once you have that set up, you can need to create a container. So I'm going to call this a copied VHDs container. And this is, if you're new to Windows Azure Storage, basically a container, you can think of it like a folder in the cloud. So in your storage account, there's a folder called copied VHDs, and I'm going to put this VHD inside of it. And to actually start to copy off, I'm using the start copy Azure Storage Blob commandlet and passing it the source, the container, and the destination. Now, what's really unique about this implementation, or what's really useful about it is asynchronous. So I can start that copy off. I can start as many as I want to, 5, 10 VMs, and it will all just kind of run in the background. Your script doesn't wait. You can actually just start all these copies asynchronously. If you ever use the Node.js tools to use this, because they have similar functionality, they are async. So you start the upload, and literally your console will wait until the service is copied, or the VHD is copied. So your console could be there 14, 20 hours, depending on how much data you're copying back and forth. So this one is completely async. We give you a separate commandlet called get Azure storage blob copy state to retrieve the copy status. So you could write loops and detect when it's done, some alerts and all that good stuff. So I'm going to copy this VHD over to MW storage. If we look at that container, there's absolutely nothing in it. So okay, so now the copy has started. We've told the Windows Azure service to start copying that VHD, and you can see the status. Right now it's just pending. It sees the source, and it shows you how many bytes copied, which so far is up in 0. But we can come back to this in a few minutes, and you can start measuring the progress by just running that last command over and over again. So let's talk a little bit about virtual networking. How many of you have ever deployed a virtual network in Windows Azure? Oh, no one. How many of you have an interest in someday deploying a virtual network? Okay, so at least you're optimists here. So if you're brand new to Windows Azure, you don't know anything about virtual networking, let me give you the crash course of the capabilities. There's probably another session to actually learn how it works. But virtual networks give you two things. Whenever you create a virtual machine or a virtual network in the cloud, just with no hybrid connectivity at all, it gives you static IP addresses. Not exactly static, but really, really, really long-term leases. So if you want to deploy applications like DNS or Active Directory that require the IP address not to change, a virtual network is really the only way you can do that. The second thing it gives you is it does give you the ability to have a connection back to your on-premise network. So if you're in an enterprise, you have an on-premise data center, and you need servers in your cloud to be able to connect back on-prem, then this is the way to do that. It can connect over a VPN tunnel using a Cisco or a Juniper device. The third thing it gives you is the ability to span these cloud services. Remember, I've been talking to you about these containers, right? We create a cloud service, we put virtual machines or other cloud services into it, and we can take all of these and put them in a virtual network. So I can have a cloud service that has all my SQL servers on it. I can have a cloud service that's managed by another team with all my file servers. And then I can put them all in a big, happy virtual network, and they can talk to each other. So it's basically a way of networking out your cloud deployments. Now, the reason that's interesting from PowerShell is because as a PowerShell perspective, you have to tell PowerShell which virtual network to deploy to. So I'm going to walk you through that, and I'm going to show you a little bit more about how the virtual network is set up too. So that way, someday, whenever you do start setting this up, you'll have a better introduction on it. And since we're here, let's just check the copy status of this commandlet. Oops, an error because I tried to create the container again. So you can see that we are actually copying. We've copied, I don't know how many bytes it is, but a lot. And we're slowly progressing, and eventually, hopefully by the end of the session, we'll have copied all 32 gigs across West Coast, East Coast. Okay, so let's look a little bit about virtual networks. So just to terrify you, I'm going to show you my configuration for my virtual network. So it's not that scary, actually. It's just a bunch of XML. But so I have a virtual network configured here. I am pointing to, I have an on-prem DNS server. This 192.168.1.6 is actually pointing to a really old, junky machine under my desk back in Washington. But it does have Active Directory on it, and it's really good for doing demos. So the second piece of information here is the VPN gateway address. So this is the IP address of my Cisco device that's sitting on that same desk that Windows Azure reaches out and talks to. Now, we're not going to do a whole lot with configuring a VNet today. Just knowing that it is connected and it's doing hybrid connectivity is enough for this session. But one other thing is the 192.168.1.0. This is a local address space of everything that's defined on my on-prem network. This bottom address, 10.1.0.0, is all the IP addresses of the VMs that I'm going to spin up in the cloud. So my cloud will spin up on 10.1.0.5 or 6 or whatever, and it will have direct network connectivity back to the 192.168 address space on-prem. So if you look at this in a portal, definitely much prettier. It has nice graphics, tells you if it's working, really useful. Now, what does that mean from a PowerShell perspective? What I want to show you how to do is, actually, I have a really long script that you don't have to just ignore most of it. But what this does is this is actually going to boot up a virtual machine up in the cloud, and it's going to use the -Windows domain parameter set. Instead of -Windows, it's going to use a Windows domain, and it's going to join this VM directly to the domain. So that's why I have to have all this domain credentials. So this is my domain user account. This is going to be the local admin on the box, the service name, basically all the good stuff that's needed to domain join this VM. Now, where it gets interesting is whenever you actually do create the VM itself. So let me break this down a little bit to make it easier to read. So new Azure VM, whenever you first create a container, when you first create the cloud service, is the only time you can ever actually set what VNet it'll be deployed into. So the very first VM you create in your cloud service, you also need to make sure and specify the VNet name if you're deploying in a VNet. So we're specifying the VNet name here, and we also need to specify the affinity group that the virtual network is created in. Affinity group is very similar to a location, except it's a much tighter area within the data center, so all the machines are much closer within that same data center. And specify my VM configuration as a parameter. So I'm going to go ahead and run this. And whenever it provisions, it'll provision inside the VNet, and hopefully it'll be in the domain join. Question? So, good question. So I got the name of the affinity group by using the get Azure affinity group. Whenever you go to create the VNet, you have to specify the affinity group as well. So if you look in the VNet configuration, that's part of that. But there is a little wiring behind the scenes that you have to know about. You have to know that when you go to create your virtual network, that it doesn't get created in a data center, it gets created in an affinity group. So you go create the affinity group first in the data center that you want, then you create your VNet, and then when you go to create your VM, you'll create the VNet inside of the affinity group. Eventually, we're going to make the PowerShell commandlets where you don't have to know that, because we can actually discover which VNet you're wanting to deploy to. But until then, you have to know what that affinity group is. So this one will be running along for just a little while. Now the next thing I want to show you is now that this, I'm showing you how you can create a VM that's domain joined, but what if we actually wanted to extend the domain controllers out into the cloud? What if we wanted to spin up a new domain controller? We could certainly do that. Part of this, the old way, prior to today, how you would do this is you would log into this virtual machine, you would go add the domain controller roles and walk through the wizard and extend the AD forest out to the cloud. With Remote PowerShell, though, we can actually, from a DevOps perspective, automate that entire task. So I'm going to show you a little bit. We don't have to go into all of the details on how this works, but just so you kind of get the capabilities here. So this one is essentially it's running the exact same code. I'm creating in the Fabricam domain, giving it a VM name, the domain admin user account. The only thing I'm doing differently is at the very end of this, I have a wait for boot flag. So whenever this virtual machine boots up, it will be domain joined, just like the one we just created, but it's also going to wait until the virtual machine is all the way booted up, and then we're going to run a couple of scripts. So one thing to notice is I've attached a data disk to this VM. It's my DIT drive, and the reason you have to do that, if you're planning on deploying AD, always make sure you put the AD, the Active Directory database on a data disk, because the C drive in Windows Azure has cache writes enabled on it. So there could, if you just leave everything on your C drive, it could lead to corruption on your database. Data disks do not have that. They have no caching enabled whatsoever, so they're really safe for doing writes. So I have an AD server booted up with a data disk provision on it. And the first thing I want to do, though, because these disks boot up and they're not formatted, right? You literally have to go into Computer Manager, Disk Manager, format the disk, and do it exactly how you want. So one of the things we've enabled with Remote PowerShell is you can run a script remotely. So we have a script here, format disk.ps1, that will basically enumerate all the disks on the VM. Any that are not initialized, it's going to go ahead and initialize them and format them for you. The second script we have is a really long script called configure.dc.ps1 that basically will, once the disks are formatted, it will log into them using Remote PowerShell and configure AD and deploy a new domain controller for you. So the benefit of doing Remote PowerShell is, yes, you have to write the scripts once, but now, this could be a SharePoint farm, it could be a SQL Server cluster, it could be any workload that you do, you can literally write a script and automate the entire thing end to end now. You don't have to provision the infrastructure and then log in and it can automate it. You literally provision the infrastructure, wait for it to boot, and then can finish the customization. So I'm going to go ahead and kick this off. And I don't remember which password I specified. So this might not work. Let me see here. I don't want to break my big demo, so. All right, I know what it is. Oops. Okay. So now it should, assuming I got the password right in my head, it should create the virtual machine. Once it's booted up, it'll log into Remote PowerShell, format the disks. Once they're formatted, log in and just deploy AD on the right drive even. And of course, this one will take minutes to get through, so like a good cooking show host, we'll switch to something else. Okay, so now I want to talk a little bit about architecture of Windows Azure, actually deploying servers and how to make them scalable and highly available. How many of you know what an availability set is? All right, good audience. So availability sets are really important whenever you're deploying virtual machines, or mostly virtual machines. So what I want to talk about is how you can take two sets of machines, say it's two web servers, two SQL servers, two Active Directory domain controllers, and make sure that you get a really high SLA, that you hit 99.95% or better uptime. And how you do that is with availability sets. Whenever you create a virtual machine, one of the options in PowerShell and in the portal is the option of giving an availability set name. It doesn't really give you a whole lot of context of what that actually means, though. All it really does is whenever you take two virtual machines, give them the same availability set name, it tells the Windows Azure Fabric controller to group these on separate physical hardware in the data center. So they will have redundant power supplies, they'll have redundant NICs, everything. The second thing it tells them to do, in addition to highly available hardware, it tells the Windows Azure Fabric controller not to update them at the same time. Because we do occasionally go back and we have to update our Fabric controllers, which means we have to reboot your machines every now and then. And whenever we reboot your machines, if they're in an availability set, we don't do them at the same time. So you'd never see downtime from that update. So the second feature I want to talk about is load balanced endpoint sets. Everyone probably knows that you can do load balancing in Azure. We can configure the load balancer and make two machines handle round robin requests. One thing that most people don't know about is that you can use health probes. Health probes basically allow you to configure your load balanced endpoints or the load balancer to react if one of your nodes is down. And it's not real advanced rules. It's really just, hey, take this node out, don't serve a 500 error if it's crashing, or it could just mean, don't try to connect to the SQL Server again. Wait till it's back up and running. So to talk about an end-to-end highly available solution, at a minimum, every tier of your application is going to want to have at least two nodes, right? This is how Windows Azure PaaS services or cloud services work today. And this is really how you should design your virtual machine architectures if you do want that high level of availability. So your databases would have an availability set. So if one of them goes down, the other one can still service requests in a clustered environment or a mirrored environment, I would say. And same thing with web servers. It's not enough just to load balance the two, because if we do update, the load balancer will not know if they're down unless you have the health probes. So how health probes work, and we can do health probes at two different levels. We can do HTTP probes, or we can do SQL. So HTTP works pretty interesting. What we can do is a load balancer basically is going to pull virtual machines, your health check page, every 15 seconds. So if your page returns anything other than 200, which 200 means okay in HTTP lingo, then if it returns anything other than 200, so if it returns a 500, a 401, access denied, whatever, the load balancer is actually going to stop sending that node traffic. Now the beauty is we actually do continue polling. So if you take the virtual machine down for maintenance, whatever, you could set a flag in your web config, hey, I'm changing this, and the load balancer is going to read that and automatically know not to update your virtual machine anymore. However, whenever you're done, you want to put it back in service, you just reverse that change, and we'll pick it up in the next 15 seconds and we'll put it back. One of the things that we've updated in the recent release is the ability to change those timeouts. Right now it's 15 seconds intervals, and yeah, so it pulls every 15 seconds, but you can actually change that to be longer duration if you want to, or I think shorter, up to 5 seconds. So we can do the same thing for TCP ports as well, though. So TCP, we can do load balance, or we do the same traffic. We ping we try to do a socket connect on the port that you specified in the probe every 15 seconds. If we don't see an ACK, we're going to stop traffic to it. But we will continue polling to see if it actually does work. So I'm going to walk you through showing you how you can do that. And one thing to keep in mind, if you're a PaaS developer, if you use cloud services, the health probes actually work on PaaS as well. You define them in the service model. So I don't have a demo to show you on that today, but if you want to learn more about it, shoot me an email offline or contact me. But what I'm going to show you today is how you can set this up for a TCP service. You can see our domain controller is still chugging along. We're running disk part right now, so eventually it'll get formatted and start deploying AD. So what I want to show is how you could configure a load balance SQL server. And obviously load balancing and SQL doesn't always work together, right? Because you can't write to multiple databases in a round robin. But what you can do is you can use this SQL servers in a read-only method for reporting. SQL Server Always On supports multiple mirrors that you can access in a read-only fashion. And this is a really good scenario if you have a reporting application that needs to read from those read-only instances. So this is showing you how you could actually create the virtual machines. I mean, we've already seen how to set that, seen how to set the availability set. But what's interesting is this Add Azure Endpoint port. What we're doing is we're setting these up on 1433, and we're telling it to, adding a couple of additional parameters, the probe protocol and probe port. Oops. This is how we set up that health check on TCP. So whenever we configure this, Windows Azure Load Balancer will literally try to connect on 1433. If it gets an acknowledgement, it's good. If it doesn't get anything, if it doesn't get an acknowledgement at all, then it kicks a node out of the load balancer. So I have 2 virtual machines already configured with this setup. So I have SQL 1 and SQL 2. Now I do want to show you what the availability set looks like. If you've never seen the availability set configuration, this is what it looks like in a portal. You can set this from PowerShell at boot time, or later if you forget, you can actually go back and change it later, or you can set it through the portal as well. Basically, you'll want to give these both of these virtual machines the same availability set name, and now they're more highly available than they were. Now if I look at the endpoints, you can see I have SQL 1433, and it is yes load balance. The portal doesn't show you any of the load balancer probe settings just yet, so the only way you can actually access those are from PowerShell today. So let's go ahead and jump over to an app that uses this. So I have a really cheesy website called Azure Store. As you can tell, I put a massive amount of work and design into making this work. But one thing it does do is it uses SQL full text search. So if you're using SQL Azure today or Windows Azure SQL Database and you wish you had full text search, this is why I chose SQL Server, because it does. I can put SQL Server in a VM and I can have full text search. So how do I know that's actually being load balanced, though, is a question. So I have SQL 1 already loaded up. Let me turn on the profiler. I can go over to SQL 2. Start the profiler there as well. Now I can go in here and just hit refresh a couple of times. And you'll see that it does have some requests come through. Only on one, because I only ran it once. It's actually a lot easier to show load balancing if I give it a little bit more load. Oops. So I have a PowerShell script here that does just that. Oops, wrong one. So all the script does is it spins up a couple of threads and it goes off and hits that website over and over and over, just so you can see that eventually the load balancer does kick in. Okay, so you can see we're getting traffic on both of these. And the app still works. Oops, let me get rid of that. Okay, now the beauty of this is I can go into SQL 2, for instance, and I can literally just kill the machine. I don't have to make any kind of application changes on my app side because I'm just pointing to one public IP address. And SQL Server or the load balancer will be smart enough to take this out of this node out of the load balancer. The only trick is it's going to only check every 15 seconds. So there could be a 15 to 25 second gap when your users would actually see an error if your SQL Server went down. So we can right click and hit stop. Yep. And trace filled, so we know we're dead. So now the application is still going to respond. And if I'm lucky enough to be load balanced over to the other node, you might see an error. But in the next 15 seconds, that won't happen because that node's completely out of the load balancer. So nice, handy little piece of functionality you get for building highly available apps just with a couple of configuration changes. It's one of the ones that's not so well known, so I like calling that up. Okay, so let's talk a little bit about cloud services. We've been talking about virtual machines the whole time. So I'm going to talk a little bit about how to deploy and package up Windows Azure Cloud Services. So how many of you are cloud services developers or have to deploy cloud service packages? Okay. So basically from the PowerShell Cmdlets, we give you the ability to deploy your CS package in service configuration files. And this could mean deploying to a virtual network, just like you can with virtual machines. We can also allow you to restart, reimage, and change your instance role count. We can change your configuration, so you can, if you want to modify the config, you can pass that and actually do an update. We give you a new upgrade mode. So if you've previously have scripted this out, figure out how to do it right with automatic and manual, we've introduced a new upgrade mode called simultaneous. And I'll explain what simultaneous does shortly, but just know that it is a much faster upgrade process. But it does have some small downtime, so it's really for the dev test staging scenarios. And finally, from the cloud service management side, is we also have scaffolding Cmdlets. Not sure how many people use these because these are very developer focused, but the general idea is from a command line, you can generate a package for a new application for Node or PHP or whatever. So let me jump into some PowerShell code, and I can show you how to actually deploy a cloud service. So first off, I'm going to explain to you what a cloud service is, so it looks like not everyone is fully aware of what these are. So if you're not a developer, just bear with me. All this is we're in Visual Studio. I have 2 projects. I have a web role and a worker role. What a cloud service gives me is it gives me the ability to easily define what my instance should be and what size. So for my website, I could have 2 instances or I could have 50. It all just depends. And what makes that decision is literally this little text box. If I typed in 50 and hit deploy, I would literally deploy 50 instances of this application. I don't have a quota for that, so it wouldn't actually work. But if I did, the capabilities are there. Now, what's interesting about PaaS or cloud services is I basically create my entire application in Visual Studio, every dependency I possibly can have with this, unless I'm connecting back to some external resource, and I can then package it up. So what that could mean is I could easily publish from Visual Studio. I could just hit publish and actually upload it from Visual Studio directly to the cloud, or in a more controlled environment where people like doing testing, imagine that, I can take this package, or take this and package it up. I can pick the debug build, or I can pick the release build. I can enable remote desktop for troubleshooting. And this is going to take the entire application, package it up into 2 files. Okay, the CS package and the CS config. Now the CS config file is just a text file. So if you open this up and look, it's basically the same stuff that we saw in the GUI, the instance count, and a big long blob of configuration settings. And the CS package file is actually a zip file that contains all the binaries for my application. So we can take this path, and if I wanted to have an automated deployment solution for this, if I wanted to deploy it for staging and tests and all that good stuff, I could literally, just like before, select my subscription. Oh, thank you. And that would not work. So I'll go to a non-remote session. Wonder why I didn't get IntelliSense. Create a new Azure cloud service. Tell it which data center this would go in, which would be West US. And now this is going to create the cloud service for me, the container, and then I need to have a separate command to actually upload that CS package and that CS config out to the cloud. So to do that, I need to know the paths to these 2 files. So I'm going to make a variable with that package and one for the config as well. And now I can say new Azure deployment, give the service name my MMSCS123, the package, configuration, and slot. So in cloud services lingo, we have 2 different deployment slots. So I can upload my application out to a staging slot where I can use it for testing, make sure everything works, and I can also put it into a production slot. Really, the only significant difference between the 2 is that production is going to have a DNS name, and staging will have a DNS name that contains a big GUID, so you can't really use it for anything other than just testing. So I can go ahead and put that, I'm going to deploy this one in staging. I can have a couple other options here. I can tell it to do not start if I want to do something special with it. But that's, for the most part, it. Now what this will do is the commandlet is going to, it's going to fail first. And we'll figure out why it failed. That's not good at all. Okay, that is bizarre. Let me grab one that I think I've already done. Maybe I typoed the paths. Nope. Something about the package it doesn't like. Let me try one more time. See, something broke during the packaging. Maybe because I opened it up in Notepad before it's finished writing. So lesson learned, don't open files in Notepad while you're packaging them. Okay, so I'm attempting to repackage that. Oops. All right, it claims to be done, so let's try this one more time. All right, I give up on it. Oh, that's actually fine. So that error is because the new Azure service worked first. And it's saying, hey, you already have a service here. So the new Azure deployment code is actually running fine. So basically, this is kind of a confusing error. So if you ever see the specified DNS name is already taken, this means that your cloud service name, and this applies for VMs as well because you'll get the same error, the service name that you picked is already taken. And it says my slot's already there. Okay, so let's, whatever it did last time, it didn't agree with. So I'm going to give it a new cloud service. All right, much prettier. Less red, the better. So this is essentially the task that you would do if you have PaaS services that you're deploying out to the cloud on an automated basis. You can deploy this out to the staging slot, and once you've tested it, we have another commandlet called move Azure deployment that basically swaps it off for production. So you can verify it in staging, swap it to production, and then do another deployment staging for testing. It's kind of how you have your application life cycle. And if you're doing this through TFS today, I think for cloud services, we support TFS deployments. They're doing the exact same thing. I actually think they're using PowerShell commandlets too. So while that one is chugging away, let me show you how you can do an upgrade while it's deploying. So we haven't even got the code deployed yet. We already figured out that we want to do an upgrade. So I'm going to take these same variables and pipe them over here, except this time what I'm going to do, hold on. Okay, so I'm going to do an upgrade. Actually, let me browse out there just to make sure it actually does work. Okay, so here's our cloud service. If I hit this URL, hopefully one of them will load, and of course not. So something about that package I just created is not very happy with the Windows Azure today. Oh, hold on. I know why. I deployed it to staging. And they're actually in the starting slot. No, I'm sorry, I did deploy it in production. Thought I did staging. So right now the VMs are still starting. That's why I couldn't connect to it. So while it's starting, I'll show you how to upgrade it for whenever it ever does. And the reason why I'm really trying to get to the point where I can show you how to upgrade is because deployment is actually really slow sometimes in cloud services. As you can see, we just deployed a web app and it's taken already 4 or 5 minutes just for the VMs to get booted up and running. But what we can do is, let's make a code change. Okay, so this is our upgraded package. So I can go ahead and hit package. And this will generate the new package file with all our fancy new code changes. And to do an upgrade, we have the exact same configuration, same package file, except it's going to use the new one. Tell it the service name I want to use, the package, configuration. And now I have a mode. Oops. This is a new mode called simultaneous. And what's nice about this is whenever you go through, remember how I told you earlier about availability sets? We don't take both down at the same time for upgrades. We do the exact same scenario with cloud services. So if you have multiple worker roles and you have multiple virtual machine instances, whenever we do an upgrade, we take one node down, upgrade it, bring it back up, take another node down, upgrade it, bring it back up. And during a dev test, whenever you're revving really quickly in a staging environment, that can be really slow. It can take anywhere from 5 to 10 minutes to deploy your application. What simultaneous mode does, it says upgrade them all at the exact same time. Don't worry about it. I love downtime. It's great. I just want to make sure the code gets upgraded. So it cuts your upgrade time anywhere from 5 to 7 minutes all the way down to 15 to 80 seconds. In the seconds range. So I'll show this if our nodes ever get started. I don't know how well it would behave to upgrade nodes that aren't even up and running yet. Simultaneous mode is available in Visual Studio. So if I go through, I'll show you where that is. Because that's a good question, because I've been asked that a couple of times because people never notice it because it's buried. Whenever you go through the Publish wizard on Settings, if you click Advanced, there's a button here called Deployment Update. There's a simultaneous update too. So yes, from a pure Visual Studio perspective, you can do the exact same thing. And Visual Studio actually implemented this on their own on the client side. And we finally moved it where we built it on the server side, and they actually just switched to using our new implementation. But fundamentally, it's the same concept. We just paved them over. OK, so it looks like this app is up and running. So it says, now I don't trust it. All right, well, I give up. This cloud service should be up and running. Something is not agreeing with me, though. Oh, hold on. I know why that one's not working. I was clicking on the wrong one. All right, so persistence pays off. I have now deployed a simple application. So now I'm going to attempt to upgrade it. Let's see how many failures we can have for an upgrade. So I did the exact same thing. This should be the same amount of time that you'd see in Visual Studio for doing deployment. It still has to upload the package to storage, so it's still going to take a few minutes, depending on how big your CS package file is. But once it's uploaded, it should be a lot faster to actually get the deployment through. When I was testing this earlier, it was taking about 45 seconds. So since I'm in front of a bunch of people, it'll probably take 5-10 minutes. But while we're thinking about this upgrade, does anyone have any questions so far? Is there any keen interest in any feature requests for PowerShell 2? One of the things I'd like to do is, since I'm the program manager for it, we figure out what we could do. If you have any ideas in the back of your head, things that we could make your life easier as an Azure developer, definitely let me know, and we'd be happy to look into them. Okay, so you can see the upgrade did go significantly faster than a new deployment. So let's see if it actually worked. And did I put my change at? You know, I don't think it did. So I will blog about this, and if you're ever curious why this bizarre demo did not work right, I will tell you. I'm sure it has something to do with me putting this in the wrong directory somewhere. But for the most part, this actually does work. I've never seen it not fail until up here, but that's okay. So that's pretty much it for PowerShell today. What I hope you saw is you saw lots of automation. We showed how to provision multiple virtual machines, showed you about new remote PowerShell so you can spin up and actually bootstrap a virtual machine and deploy DC, and just kind of use your imagination of whatever other workloads you could automatically spin up. If you do want to know the outcome of why that bizarre demo didn't work, ping me on michaelwasham.com. I will put a blog post up there eventually and explain it. Question? So the question was, PowerShell today, PowerShell 3.0 supports PowerShell workflow, which means you can do automation and all kinds of workflow-y type activities. We do not have any immediate plans to integrate that directly into the PowerShell Cmdlets, but we have a lot of customers that are using our Cmdlets with workflow today. So they're using our primitives and workflow to do really advanced orchestration of deployments. But it's certainly something we should be looking into, just because now that we can bootstrap virtual machines, you can think that there's a lot more advanced scenarios we could do, especially with a workflow environment. Any other questions? Awesome. All right, thank you very much.